Good afternoon, Standard 10th. Today we'll continue with our chapter of locus. Yesterday we discussed certain important locuses with you. Today we are going to do some few theorems. Actually there are two theorems and two converses of those theorems. So we will be discussing 4 theorems in total. Now let us see the first theorem. What does it talk about? It says the locus. We told you what is locus. The locus is the path. Locus, it means the path described by a moving point under certain mathematical conditions. Certain mathematical conditions. Like it says the locus of point which is equidistant. The locus of point which is equidistant from two fixed points, is the perpendicular bisector of the line segment joining the two fixed points. What does it say? Please hear it once more. The locus of a point P, he has not written point P, I have taken a point P. The locus of a point which moves such that it is equidistant from two fixed points. Here P is the moving point, you can see in the figure, and A and B are fixed point. Then this point, the locus of this point will be the perpendicular bisector of AB. That means the P will lie on the perpendicular bisector of AB. If I perpendicular bisect AB, then P will be lying on that. We have to prove that P lies on the perpendicular bisector. What is given? A theorem has a particular method. A theorem has to be written in a particular format. The first thing is that he'll give you the statement. Like we have given you the statement. The locus of point which is equidistant from two given fixed points is the perpendicular bisector of the line segment joining the given two points. Now P is the moving point, A and B are two fixed points. We have to prove, and it is given that P is equidistant from A and B. Equidistant means at equal distance from point A and B. Now given is A and B are fixed point, two fixed points, and he has given you PA is equal to PB. P is a moving point. P is a moving point, and we have to find the locus of this point P such that PA and PB are given equal. PA and PB are given equal. Now, required to prove is that P will lie on the perpendicular bisector of AB. So, what is the construction? These are the steps we have to write in the same order. Statement, figure, given, required to prove. If there is any construction, we'll join A to B. Suppose Q is the midpoint, join P to Q. It is the midpoint. Q is taken as the midpoint, we join P to Q. We are saying join A to B, join P to the midpoint of AB. We have taken Q as the midpoint of AB, we have joined P to Q. Now you can clearly see there are two triangles, and as usual, as I told you yesterday also while in my discussion, that we have to use the conditions of congruency of triangles too often. Here I am going to use also the condition of congruency. What is the condition? Now let us see the proof. In the proof, we have the statement. And we have the reasons. Now in this statement we will say in triangle APQ and triangle PQB. Let us take these two triangles. We are going to prove these two triangles to be congruent to each other. One of the conditions of the congruency will be satisfied by these two triangles. And what is the condition? Let us see. We will say that AQ is equal to QB. AQ is equal to QB. It is given. We said Q is the midpoint of AB. So it is given to you. We said AQ is equal to QB. It is given to you. Then we are saying that PQ is common. PQ is common. PQ is equal to PQ. PQ is equal to PQ, common side. Always write this statement on one side, reason on the other side, because it is very important in theorems to mention the reason. If you don't mention the reason, you may lose marks. Now, AQ is equal to QB, the reason is given. PQ is equal to PQ, it is a common side. And AP is equal to PB. AP is equal to PB. It is also given. If you see what is given, you will find here. Given is A and B are fixed point, PA is equal to PB. AP is equal to PB or PA is equal to PB, one and the same thing. So all the three sides of this triangle are equal to all the three sides of this triangle. The three sides of one triangle are equal to the three sides of the other triangle. Hence, two triangles are congruent because SSS, when all the three sides of one triangle are equal to all the three sides of the other triangle, 1 to 1, then we say that this is one of the conditions of congruency, which is SSS. So triangles are congruent. So triangle APQ is congruent to triangle PQB. And what is this congruency is SSS. Now what does it prove by proving the triangle to be congruent? What do we achieve? We have to prove that this is the perpendicular bisector. We know it is a bisector. We know it is a bisector. Why it is a bisector? Because Q is the midpoint and we have joined P to Q. So it is bisecting. The line PQ is bisecting AB. The only thing which I have to prove is it is perpendicular. I have to prove this angle and this angle to be 90. Then only I can say it is perpendicular bisector. For that, what I am going to say is that angle AQB will be equal to angle, PQA. Angle PQA will be equal to angle PQB. CPCT. What is CPCT? Congruent part of congruent triangle or corresponding part of congruent triangle. These are the corresponding angles of the congruent point. Because we are saying PA is equal to PB, we are saying PA is equal to PB. In front of PA, the angle is PQA. In front of PB, the angle is PQB. So these two angles are equal to each other. These two angles are equal to each other, and hence these two angles are corresponding part or congruent part of the congruent triangle. And if these angles are equal, so they are going to be nothing but equal to 90 degree. Why are they going to be 90 degree? Because AQB is a straight line. AQB is a straight line. Because if a straight line is being divided by another line into two equal halves, 180 will be divided by 2, that will be 90 each. That means this PQ, that implies PQ is perpendicular bisector, perpendicular bisector of AB. It is perpendicular bisector of AB. It is perpendicular bisector of AB. This is perpendicular bisector of AB, and that is what we had to prove. What did we have to prove? Required to prove was that P lies on the perpendicular bisector of AB. So when I am saying PQ is the perpendicular bisector, so P is lying on that line. That is why I am including P into that statement. PQ is perpendicular bisector of AB. Why it is bisector? Because we had already assumed Q to be the midpoint, and it is perpendicular because we are proving the angle to be 90 degree. So once again, I'll just go through it quickly so that you understand once again. What was the statement? The statement was the locus of point which is equidistant. Equidistant means at equal distance from two given fixed point. What are the fixed point? A and B are any two fixed point. P is any point which is equidistant from A and B. P is a moving point because moving point only will trace a locus. So P is a moving point, A and B are fixed point. And it says P is equidistant from AB, then P will lie on the perpendicular bisector of AB. P will lie on the perpendicular bisector of AB. So what do I do with, first of all, what is given? I'll say A and B are two fixed point and P is a moving point. P is a moving point. Required to prove will be, we will have to prove that P lies on the perpendicular bisector of AB. P lies on the perpendicular bisector of AB. So what did we do? We found the midpoint of AB. We found the midpoint of AB. Q is the midpoint of AB. And we join P to Q. We join P to Q and we join P to A and P to B. So the two triangles are formed and I proved these two triangles to be congruent by the condition SSS. I said PQ is equal to QB because Q was the midpoint. We had assumed Q to be the midpoint, so it is given. I said PQ is common. PQ is equal to PQ. PQ is a common arm. PQ is a common arm. And PA is equal to PB. It is given. It is given. So all the three sides of one triangle are equal to the three sides of the other triangle, each to each. Hence the two triangles are congruent. And when the triangles are congruent, they are equal to each other in each and every respect. Each and every, we have already proved the sides are equal, so the angles will be equal. And how do I find the corresponding angle? We have told you while discussing the congruency that corresponding angles are in front of the equal sides. For example, AB is equal to QB, PB. In front of AB, the angle is PQA. In front of PB, the angle is PQB. So PQA is equal to PQB. And these are nothing but 90 degree each. Why? Because two straight lines are meeting each other, so the adjacent angles will be divided into equal parts and each part will be equal to 90 degree. That means PQ is perpendicular and it is also bisector. So P is lying on the perpendicular bisector of AB. This is the first theorem. This is the first theorem. After this we will discuss the converse of this.